Okay, this week we're going to look at standardizing variables. And this is something that we're going to need to do in the event that we are creating a new construct from two or more variables, like we did last week in the compute variable video. But this time around, let's say the scales of our variables of interest are not identical. We're going to need to add one extra step before we compute our variable, and that's going to be to standardize our variables into z-scores. So let's dive right in. So let's say we are interested in the relationship between an interest in politics and good vibes. To what degree is interest in politics related to being a chill person with good vibes? So we have one variable that fully captures our construct of interest in politics. And I've hand selected three variables that we're going to combine together to together represent chillin' with good vibes. So let's look at what the values represent for each one of these variables. So if we look at importance of leisure time, a 1 is representing very important and a 4 is representing not at all important. If we look at the importance of having a good time, we see that a 1 represents very much like me and a 6 represents not at all like me. And if we look at feeling of happiness, we will see that a 1 represents very happy and a 4 represents not at all happy. So two things to note before we move on here. One is that these scales are not identical, in which case we are going to have to standardize these variables, and we'll dive right into that in a second. The other thing to note is that all three of these scales are in the same direction, which is a good sign, because if they were in different directions, then we would need to recode them so they're all headed in the same direction. And what I mean by that is that for all of these, the highest number is going to represent the least amount of the variable, or it's representing the most negative response. And our shortcut here is to see that the highest number for all three of these say not at all. So 4 represents not at all here. The highest number, 6, represents not at all. And a 4 here represents not at all. Now let's say we had that reversed, where on one variable the highest number represented not at all, and the next the highest number represented very important, or very whatever that variable is. Then we would need to recode that variable so that it is headed in the same direction as the rest of the variables. Okay, so now we want to standardize these variables. So I'll have you go up to Analyze, click Descriptive Statistics, go to Descriptives, and we're going to drag over our variables of interest. And all we're going to do here is click this little box in the bottom left corner that says Save Standardized Values as Variables. And what this is going to do is it's going to create three new variables that are representative of the three variables we have here, converted into standardized variables, and in this case, z-scores. So we'll click OK. And if we close that box or minimize that box, we can see three new variables that mirror the variables that we were looking at, with the added z-score labels at the front of the labels and an added capital Z at the beginning of the name. And this is to indicate to us that this is not the original data, this is our standardized data. Now if we go over to data view, we can see a whole bunch of numbers here, and you might be thinking, what do these numbers mean? I'm gonna do a quick little exercise here to hopefully highlight that a little better. So we're gonna go back to Descriptive Statistics. We're gonna click Descriptives, and this time we're just gonna look at one of these three variables, and we're gonna drag over the corresponding z-score. We're going to click Options, and we're only interested in the mean and standard deviation here. We're going to click Continue. Oh, and we're going to unclick Save Standardize Values as Variables. And we'll hit OK. Now I'm going to do a little two-screen action here. And we're going to open up the dialog box for the values of feeling of happiness, just to remind us what these numbers represent. So if we go over to our output and look at these numbers, we can see that the average or mean score of feeling of happiness is 1.93 and the standard deviation is 0.739. So that means on average folks are a little more than quite happy, and most individuals, 68%, are in between very happy and not very happy. Now if we look at the z-scores, we can see we have a mean of 0 and a standard deviation of 1. And this is in fact what you're going to see for every z-score you come across. In fact, that's what makes it a z-score. It's going to take whatever mean that we have and transform that to 0, and it's going to take whatever the standard deviation is and transform that to 1. That is to say, a score of 0 is going to represent the mean score, and a score of 1 is going to represent one standard deviation to the right, and a -1 is going to represent one standard deviation to the left, and that will keep going. A value of 2 represents 2 standard deviations, a value of 3 represents 3 standard deviations away from the mean, and so on. So if we go and look at the numbers here, we can see, just to kind of confirm what we're looking at, we can see a value of quite happy, which is, remember, is the closest value we have to our average, and we indeed see that the z-score is the closest number to 0 that we have in our values. And if we look at, say, very happy, we have a -1.2, so that represents a little more than one standard deviation to the left. And if we look at not very happy, we have a 1.4, which represents a little more than one standard deviation to the right. All right, so the only thing that we have left to do now is to compute our new variable. So we're going to go up to Compute Variable, and we want to average these three values together. And we're going to do that by adding them together. I'm going to divide by 3 because that's the number of variables that we're working with today. And the target variable is going to be called Good Vibes. I'm going to click OK. And we'll take a look at our variable view here. You see that we have a new variable, and we're going to label this good. We're going to label it chilling with good vibes. If we go to our data view, we can see that we have an aggregate, or a combination of the three variables we were looking at. And that's how we create a new construct from standardized variables. Okay, we're actually going to go through one extra step here, and that is to reverse our z-scores so that it better aligns with our new construct of good vibes. And we did this last week by recoding the variable, and we're going to do this in a little less tedious of a way. We're just going to go to compute variable. We're going to plug in our new variable, good vibes here. And we're going to put a negative sign in front of it. Oops. And we don't want to change the existing variable. We want to say reversed. I'll relabel this again. Chilling with good vibes. Reverse scores. And now for those who are, well, first let's look at the data view, and we can see that these are exactly opposite. So what we accomplished here was we now have made it so a larger number represents a greater degree of good vibes, and a smaller number represents a smaller degree of good vibes. Now, just for fun, we're going to actually run the correlational analysis. And you don't need to know how to do this at this point. But we're going to drag over interest in politics and chilling with good vibes, reverse scores. We can click means and standard deviations, and we're going to click OK. And voila, we're going to see that we have a significant negative correlation between our constructs of initial interest in politics and chilling with good vibes. That is to say, the more chill you are as a person, the less likely you are going to be reading the newspaper or watching Fox News or MSNBC News.